Today we're going to discuss dimensional analysis. So typically you see dimensional analysis in high school at around 11th grade, in your chemistry class or your physics class. Whenever you start to deal with units, teachers are going to start teaching dimensional analysis. It's useful for converting between units. So like if you're converting between pounds and grams, or feet and inches, or seconds to minutes to hours. You could use it in a bunch of different applications. Today we're going to look at a silly example, and I'm going to show you my step-by-step strategy for dealing with dimensional analysis. So here, if you haven't already read the question, it's how many millennia would it take to watch 6.022 times 10 to the 23 Nemo movies? So this 6.022 times 10 to the 23, if you're not familiar with that number, that's Avogadro's number. It's written in scientific notation. I did a little video on that earlier, so you can take a look at that. Here's my step-by-step strategy. Step one, we want to identify what you know and what you need to find. So we know we're trying to watch 6.022 times 10 to the 23 Nemo movies, and we want to find how many millennia it would take to watch that many Nemo movies. Okay, so that's step one. So this is, we know, and this is what we want to find. Okay. Step two, we need to research any extra information that isn't given. So if you're on a test, hopefully that's given to you. Maybe you need to memorize it, or if you're at home doing homework, you might need to do a little bit of research on the internet or something. So we know that one Nemo movie, abbreviated NM, is 1.67 hours. And otherwise, all the information to get to millennia is pretty straightforward. Step three, we're going to use fraction multiplication to cancel out units until we arrive at our solution. So just a quick refresher on fraction multiplication. I usually like to start with our given or known information first, and we can multiply across. So our given in the numerator will cancel out with the given in the denominator, and we may have, so this intermediate class right here will cancel out with the intermediate, and we can find a result through fraction multiplication. So we're going to start with our given 6.022 times 10 to the 23 Nemo movies. Just like we did in our fraction multiplication, we started with our given. And we're going to multiply it against this intermediate conversion factor. So we know that one Nemo movie is 1.67 hours. We want the Nemo movie unit in the denominator because we have it in the numerator here. So we have 1.67 hours per one Nemo movie. So right away we can see that these units cancel out, and we're in the units of hours now. So we want, for hours, we need to know how many hours there are in a day. So in one day, you have 24 hours. Again, we can see that hours cancels, and now we're in the units of day. How many days are there in a year? There's approximately 365 days in a year. So in 1 year, we have 365 days. I'm running out of room here, so I'm going to drop down to another multiplication just down here. It's still being applied. So again, we need to know how many days there are, how many years there are in a millennium. So there's 1,000 in one millennium. We have 1,000 years. Okay, now if you multiply this all across, 6.022 times 10 to the 23 times 1.67 hours times 1 day times 1 year times 1 millennium divided by 24 hours, 365 days, and 1,000 years, we would arrive at the solution of 2.75 times 10 to the 18 millennia. And that is how you do dimensional analysis. Hopefully this was useful, and hopefully you learned something.